Hello everyone, let's talk about piecewise functions. So, a piecewise function has two parts to it. You have a set of functions on the left side, and then you have a set of intervals on the right side. And what you need to realize is that this interval over here on the right is going to tell you which piece of the piecewise function you should use. So there should never be any overlap here. If it says these are numbers less than or equal to -10, then if you pick something in this interval, there should be no overlap. It's all the numbers less than or equal to 10, we'll use this piece. Anything between -10 and -2, not including -10, we'll use this piece. And anything bigger than -2, we'll use this piece. So if I say evaluate f of -10, you need to decide which piece that fits into. So if we try it here, is -10 less than or equal to -10? It is. So we're going to pick the first piece. -10 plus 12 cubed. -10 plus 12 is 2, and 2 cubed is 8. So this is 8. Now when we pick -5, we're going to kind of do the same thing. Say, okay, is -5 less than or equal to -10? No, so don't use this piece. Is -5 between -10 and -2? Yes, so we use this piece. -5 plus 4 is -1. All right, let's try some more of these. Let's try and go the other way with the graph. This says evaluate f of 1 using the graph. So if you look, there's three pieces. You have a cubic, a line, and a quadratic. Here we have a cubic, that's a cubic. Here's your line, and here's a quadratic. So if I say evaluate f of 1, you need to go to where x is 1 right here, and we're trying to figure out the y value. The y value would be right there, and that would be at 6. So f of 1 is 6. Now if we do -5, we just did -5, but now we'll do it graphically. -5 is right there, and the y value of that point, that's -5, -1. So this would be -1. And if you look, we got the same thing when we did it algebraically. We should get the same thing because it's the same function. Here's the picture. So we have a graph, and here we can do it with functions. It just doesn't matter. It doesn't matter. We should get the same answer both ways. Now, what if we try and write the piecewise function? So there's three pieces. You've got a quadratic, and then you've got two lines. So to write a piecewise function, we're going to say f of x equals, and then we put this big curly set thing. Okay, you can see that's how they do it here too. And that said, we got to have three pieces. The first one is a quadratic, and that's just the quadratic x squared. You can see it's 1 squared is 1, and then -2 squared puts you at 4. That's just x squared. But when do you use it? You use it to the left of 1, so all of the values left of 1, and the way we'll say that is x is less than or equal to 1. It's a closed circle, so we're going to say less than or equal to. For the second piece, we just have a horizontal line. That horizontal line is y equals 3, and we use that between 1 and 2. So we say 1 is less than x is less than or equal to 2. I'm saying less than because this is an open circle, so it's strictly less than, and then closed circle at 2, so we'll say less than or equal to. And the last one is a line as well, and this line looks like it has a slope of 1, and if you were to sort of work backwards, you can see the y-intercept is 0. So this is just the line y equals x, and we're going to use that for all numbers bigger than 2, so x is greater than 2, and it's an open circle, so strictly greater than. So these pieces make up that graph. All right, let's try and do this one a little trickier now. X plus 2 squared. So we can use Desmos to help us with that. I'll use Desmos to do the x plus 2 squared part. Where is Desmos? X plus 2 squared. I want you to be able to do this you're on your own, so let me show you. If you have this function, you click the gearbox and you can make it a table, and then we can find some values, and you see how it's got those drawn. You can also add values, and you can see how it's going to throw in some extra points. Okay, I can keep doing that. What do I need here? So x is less than -2. So -2 is at 0, so we'll put a dot at -2, 0 right there. I gotta use my actual stylus, it's way better. -2, 0 is right here. And then we'll say -3 is at 1, -3 is at 1, -4 is at 4, and -5 was at 9. That's off the page. But since it says strictly less than, this endpoint needs to be an open circle. And we're going to go to the left like that. Okay, that's the first part. That's the quadratic x plus 2 quantity squared. and we're only using that to the left of -2. The next one is a line, so the y-intercept is -4 and the slope is +1, so I'll draw all these points and then we'll erase what we don't need. We're only going to do this between -2 and 4, so -2 is right here. It's a closed circle because it's less than or equal to. And then at 4, it's an open circle because it just says less than. So we're going to have a closed circle and an open circle, and we're using that line between them. And the last one is a horizontal line, y equals -6, but we don't start until 4, so it's like this. And since it is greater than or equal to, we're going to put a closed circle on the end. So there's 3 pieces. You've got a quadratic, that's right here. You've got a line, that's right here. And then you've got another line, that's right here. But we only use them on the indicated intervals. All right, let's try another one. Graph the line -x plus 1. So you start at the y-intercept and you go down 1 over 1. So it's this line, but we're going to use that when it's less than 1. So 1's right there. It looks like that. Okay, that's this 1 over 1. And then it's a closed circle because it's less than or equal to. The other line, the y-intercept is -4, and you go up 1 over 1. So it looks like this, but we're only going to use that when it's greater than 1. So when x is 1, I'm going to put an open circle, and I'm going to go to the right like that. Okay, and I can erase this point. Now it says evaluate f of 7. So when x is 7, that's right here, what's the y value? The y value is 3, so this would be 3. And f of -1 is at 2. Okay, you can see f. Now, that's doing it graphically. If I were to do it algebraically, I would say since 7 is greater than 1, I plug in 7. 7 minus 4 gets you 3. And since -1 is less than 1, the opposite of -1 plus 1 is 1 plus 1 is 2. That's where this one comes from. Horizontal line, y equals 1. And I'm going to start here with a closed circle to the left of -2. So that's y equals 1. And now the other one is a parabola, and we're going to start it at -1. So it's a parabola that's been shifted down, so it looks like this. 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. I'm just going over 1, up 1, and then over 2, up 4. And then over 3, up 9, puts you right here, like that. Okay, but we're only doing this when x is greater than -1, so I don't need this one, and I don't need this one. I'm going to put an open circle when x is -1. That's right here. And then it's a parabola that goes up like that. So let's do this algebraically. First, g of 2. 2 is less, nope, that's not it. 2 is greater than -1, so 2 squared minus 1. 4 minus 1 is 3. And if you look at the graph, we should be able to go to x equals 2, 1, 2, and see the y value is 3. -4, 1, 2, 3, 4 is at 2, and that's because, or wait, I drew this at, and this needs to be at 1. I drew this wrong, right here. There we go. Y equals 1 when x is less than -2. So there, that's the actual horizontal. But you can see that when you plug that in, -4 is less than -2, you get 1. So -4 should be at 1. It's right there. So make sure you draw the y value at 1, not 2. You can see how y equals 1 is a horizontal line. All right, let's try and go backwards a couple times. If you've got a parabola that's been shifted down 3, that would be x squared minus 3. And then you have a line that has a slope 1 and a y-intercept of -1. I'm going to put this one actually on the top, because normally we read left to right. So those are the two pieces. We'll say f of x equals, and we're using the line when x is less than or equal to 0. It's a closed circle, so it's less than or equal to. And we're using the parabola when x is greater than 0, to the right of 0. This one has 3 pieces. That's a parabola that is shifted left 1. So we'll say x plus 1 squared. And let's see, I'll do f of x equals, curly brace. This is a horizontal line, y equals 1. And this is a line, let's see, what's the slope? -1, and the y-intercept is at 4. So -1x plus 4. Oops, plus 4. So when do we use the parabola? When x is less than or equal to -1. We use the middle segment between -1 and 4. So -1 is less than x is less than 4. And this is an open circle here, but a closed circle for 4. And then we use the third piece when x is greater than positive 4 with an open circle, so strictly greater than. Can't see that though, my head's in the way. There you go. All right. One more. Most challenging problem. Okay, so negative x minus 2, that's a line with slope negative 1, and it goes through the y-intercept negative 2. So that's right there. Okay. When do we use it? When x is less than negative 4. So we'll chop that off, and we'll put a closed circle. That's the first piece. Square root of x plus 2. So the square root of x plus 2 goes 2 to the left. And it would be, let's see, up 1 over 1, 1, 2, 3, 4. The square root of 4 is 2. And the square root of 9 is 3. So I'm just going over 9 up 3. And we use that between negative 4. Negative 4. Well, that doesn't go past negative 4. Okay. And positive 2. So it's going to look like this. Right? Oh, but it stops at 2. So chop off the end there. There you go. And then the last piece is a line that has a y-intercept of negative 3 and a slope of 1. So it's these points. But we don't start until x equals 2, so it's this. And I will erase these guys, and I will make sure that I make my endpoints very obvious. This should be a closed circle at 2. No, open circle at 2. That's a closed circle here. This is an open circle at negative, oh wait, it doesn't matter because it doesn't get to negative 4. And then at negative 4, it's also a closed circle. Okay, so that's kind of weird because it doesn't actually hit, negative 4 is not in the domain. F of 5, when you plug in 5, you're right here. The y value is 2. And negative 3, wait a minute. Negative 3, if you try and plug in negative 3, you get the square root of negative 1. So we could say I, but we're just going to say this is undefined. It doesn't actually have a value that is on the graph. Negative 3 is right here, and you can see that's not in the domain of this radical. So we'll just say it's undefined. All right, so, or we can say it's non-real. That's it for our piecewise functions. You should practice your delta mass, and you should smash that like and subscribe.